Good day to everyone. So today we wanted to discuss one of the topic in biomaterial, which is biomimetic materials. So what is biomimicry? So biomimicry is a practice that learns from and also mimics the strategies found in nature to solve human design challenges. And also biomimicry offers an empathetic, interconnected understanding of how life works and also ultimately where we fit in. Actually, biomimicry can bring relief, can help us to design generously, and also can get us to sustainable solutions more faster. And also biomimicry can change our lens on the world. So there are some of examples that shows the effect of biomimicry, so which are the spider webs that represent nature's ability to deter collisions, and also nature's chemical recipes can help us to design sustainable forms and also plastic. So actually, biomimicry can classify into four different types, which is functional biomimicry, molecular biomimicry, process biomimicry, and also structural biomimicry. And these four different types of biomimicry focus on different things. For example, like for functional biomimicry focus on the physical and also chemical properties of biomaterials, while for molecular biomimicry, this focus on the atoms and also molecules that are selected to produce the biomaterials. And for the process is focus on the pathway and also the mechanism where the atoms or molecules acquire their final position and also orientation in the biomaterials. While for the structure is like for the pattern of the atomic and also the molecular organization that is obtained in the biomaterials.
So for the origin of the biomimicry, so in 17th century, Robert Koch started the possibility of produce fiber artificially running from study the silkworm. But however, lacking the knowledge of molecular biomimicry of silk, 200 years was spent trying to draw the fiber from the suspension from the wood palm and also the plant sources raw material. So the first manufactured organic polymer fiber was rayon from extract from the solution of the cellulose. So in 1969, the American biophysicist Otto Skin used the terms biomimetics for the first time in the paper he presented in the International Biophysics Congress in Boston. So start from this, the humans start to apply what nature does, which refer to the biomimicry.
Now I will explain about attraction of biomimicry. The first one is biocompatibility. Surface property of a closely biomimetic material can be expected to be comparable to corresponding natural material. So a closely biomimetic material is also likely to be compatible if it is used within an environment that is comparable to the native environment.
The second attraction of biomimicry is the integration of biotechnology. With compatibility, the metabolic pathway of living organisms can be harnessed via the techniques of biotechnology to obtain control purity, economic scale up, and simple convenience in molecular biomimicry. Another attraction of biomimicry material is the environmental impact of the biomimicry materials. So we wanted to produce the biomimicry material that are compatible with the recycling that occurs in nature. So this type of properties become specifically desirable. So for example, the spider silk. So in nature, spider will produce silk in order to construct the spider web, and then in order to construct new web, or it will eat back the silk that it produced originally to produce the to degrade into certain amino acid, and thus produce new silk, so that no external resource is needed to be produced new silk.
So I will talk about the applications of the biomimetic material as a biomaterial, because for the biomimetic material there's quite a lot of applications but it's not related to biomaterial. Like the design of the bullet train from Japan is actually mimicked from the kingfisher, the bird. So if related to biomaterial, we will talk about something like antimicrobial foam mimicking the shark skin. So actually shark skin is covered with so-called dermal denticles. When in motion, these dermal denticles actually create low pressure zone and then causing the bacteria to not spawn or barnacles to attach to the skin. So based on this same idea, many hospitals also using this biomimic shark skin foam to combat cross contamination. So there's more explanation will be shown in the YouTube link later.
I'm Anthony, this is D News, and shark skin is bananas, you guys. It evolved over 400 million years to be the ultimate sleek, protective, aerodynamic coating for any sea creature out there. Sharks predate dinosaurs, so they've had a lot of time to get this right, and now scientists and industrial engineers are looking to shark skin to create all kinds of insane future technology that's going to make us 400 million years better. The secret of shark skin is this thing called a dermal denticle. Sharks are covered in them. They're like scales, but they've actually got more in common with teeth. They're set up in this overlapping diamond shape that form these little grooves and channels that pull water toward the shark and then push it across its body, which gets rid of resistance and it lets the shark move more quickly. Those little diamond shapes also keep bacteria and other parasites from colonizing on the shark, which eliminates a major issue for most other sea life. Have you ever seen the stuff that sets up shop on a whale? It is nasty. And now we're using our knowledge of shark skin to make some really incredible things. By recreating the pattern of denticles on a plastic surface, this company called Sharklet Technologies has created a material that can be used in hospitals or restaurants, any other high traffic area, and it prevents bacteria like E. coli or Staphylococcus A from taking root and colonizing. That is a huge deal because over 1 million people a year worldwide contract staph infections in a hospital, with about 19,000 of them winding up fatal. Then there's all that fancy hydrodynamic stuff. Speedo introduced its first shark skin inspired swimsuit back in 2000, and now similar technology is being used on ships. Things like algae and barnacles cling to Navy ships and cause drag, and that slows them down and costs about $50 million a year in fuel. The Navy's been experimenting with a rubber coating for ships' hulls that mimics dermal denticles, which eliminates all that drag without using chemical coatings that harm the environment. Plus, the rubber coatings are actually cheaper and last longer. Lufthansa has taken shark skin to the skies. They've been testing this lacquer on some of their aircraft that gets stamped with a denticle pattern before it dries. If the tests are successful, they'll be covering 40% of their fleet with it, which should save about 1% of their fuel costs a year, which, yes, I know that doesn't sound like much, but it's 900 tons of jet fuel, which adds up to about $94 million. Biomimicry, man. Let's take all of the animal superpowers and make them ours.
Whereas there is some of the limitation on biomimicry. The first is toxicity of natural material. This is because some natural produced material and processing bioproducts are toxic. Somehow this toxin won't be permitted in environment. And then the second is natural base may not be good enough. This is because compared with artificial one, sometimes natural one is not much strength as the artificial one. And the last one is the failure in natural material. This is because the natural material usually to achieve the successful in one species but not an individual. This is somehow different from the goal of biomimicry to be used in engineering field. When talking about the future of biomimicry in biomaterial science, first is we will use the property of lizard, how it's going to generate its teeth, and the buckhorn, how it generates its horns every year, as well as the regenerative property of spider webs. And this will give us the inspiration to create the regenerative medicine and tissue engineering. Second, we will use the foot hair of gecko to inspire people to create a biocompatible medical bandage, which is integrated with a ubiquitous U-hair to detect the heart attack quickly, which somehow cannot be detected by the current medical device. Last but not least, we will use the concept how the mosquito mouthpart that able to attract the blood from host animal with the lesser amount of nerve irritation to create a painless needle made of biodegradable polymer that will make less irritation to the patients. That's all from us. Thank you.